Okay, so now we're going to have a quick look at the alternate normal distribution tables, which you will be expected to make reference to at certain points, and we'll talk about what those situations are. Okay, these are often found accompanying the standard normal distribution tables. What these do, they offer up some z-scores for very specific situations. If you have a quick look here, it does tell us these are for when our probability is above the z-score that we're looking for. So as we read through the tables, firstly you'll notice that the probabilities are the first column and then the z-scores are second. Because here we should be looking up z-scores that match a probability that we're working with. Okay, so how do we read these tables? If I knew there was a certain value and 30% of things were above that value, I want to know what z-score has 30% above it. What z-score is exceeded by 30%? Looking in the tables, well, here's my 30%, and here's the z-score that matches. This will be a z-score of 0.5244. And I can go ahead and use that in the question and in my problem solving as necessary. Similarly, what if I had a z-score that was exceeded by just 5% of the rest of the distribution? So this area here was just 5%. So once again, I'm going to look up that percentage in the tables. It's right here. That's 5%, 0.05. And the z-score to match, 1.6449. Okay, obviously bear in mind that for this particular z-score, there's 0.05 above it. Well, how much is below it then? Below this, we're going to have 95%. So our situation could have been phrased either way. What z-score has 95% below it, or what z-score has 5% above it. Either way, when we have a percentage and we're trying to look for a z-score, it's these alternate tables we might refer to. There are some very standard numbers here. So you're not going to find 12%, you're not going to find 7%, but just be aware of the percentages you will find. So 50, 40, 30, 20, and 10. Let's not forget 15%, so multiples of 10, including the 15. And then you have 5%, 2.5%, 1%, 0.5%, 0.1%, and 0.05%. Be extremely careful when you're reading these percentages, particularly the ones with the additional zeros. So I'm talking of the 50, the 5, the 0.5, and the 0.05. All right, so questions in whichever way they want may ask you to refer to these percentage points and to these alternate tables. Okay, so let's look for a situation where that might be the case. So if we had the distribution x follows a normal, 32 and 5, probability that x is greater than a equals 0.2. All right, what is the value of a? Well, I had a percentage here, and I want to work with finding this unknown real world value. Okay, starting with the percentage can be linked to a z-score, and that z-score can be matched up to a real world value through the standardization formula. So let's try and bring all of those bits in together. Firstly, I'm going to standardize. So I'm working with the probability that x is greater than a minus 32 all over 5. And that probability equals 0.2. Okay, so we're concentrating on figuring out what is this z-score right here. Well, looking at the tables, I can see that that z-score that has 20% above it, it's going to be right here. So if I was to standardize, probability that z is greater than a minus 32 all over 5 will equal 0.2. Okay, so now I have a link. This expression for my standardized z-score should match the actual value 0.8416. If I put those equal to each other, I should then be able to rearrange and find out the value of A. Z-score should be 0.8416. And at this point, I know this is an expression for the z-score. This is the actual z-score. All right, just ready for the calculator now. And this is what I get for my value of A. A quick sense check. I am expecting something bigger than 32. So we're definitely there. I am expecting it to be less than 1 standard deviation above 32. So I'm expecting it to be less than 37, and it also fits that criteria. I'm happy that we've calculated the exact value of A. So this is how the alternate table should be used. If you know a percentage point that you're working with, you can find the z-score associated with that, and using the standardization formula, we can combine those to answer a whole new range of normal distribution problems. Okay, and let's do one more type before we look at an exam question. Okay, so x follows a normal distribution of 100 where the variance is 16. The probability that x is less than b equals 0.4. What is the value of b? Okay, so a few things to notice here. I did mention the variance, and you are given the variance sometimes in the question, but we definitely want to write this in our standard form. All right, muscle memory is going to take the value that we see in the bracket and use it straight in the standardization formula. So we can do ourselves a favor by setting that up with the normal format, with the normal syntax. Okay, so looking at this situation, let's try and graph that. Probability that x is less than b equals 0.4. All right, I'm choosing a value where the probability that it's below is 0.4. That does mean it's going to be on this left-hand side. Probability of 0.4 is going to be on that left-hand side. The probability that it's below the mean is 0.5. So if that probability is getting smaller, I'm moving off towards the left with the value I'm thinking of. All right, that brings two things to mind. Firstly, if we know 0 is right here, my z-score is actually going to be negative. If it's on the left of 0, it's going to be a negative z-score. There are no negative z-scores in this table. What we're going to need to do is to think of the reflection. I know the z-score that has 40% above it. It's right here, 0.2533. So the z-score that has 40% below it is the negative version of that. It's negative 0.2533. So be really careful to get that correct. Once again, it's the diagram that's brought that out for us. Having that in front of me made me think instantly I need a negative z-score and to set me up to respond to this question correctly. Okay, so let's go ahead and standardize. So the probability that z is less than b minus 100 over 4, well, that equals 0.4. I know that this expression for the z-score and the actual z-score that I've got on the diagram should match up with each other, so I'm going to set that up. Negative 0.2533 should equal b minus 100 all over 4. All right, so some sensible rearranging is going to allow us to figure out the value of b. So b is going to equal 100 plus 4 lots of this negative 0.2533, and that leaves us with 98.9868. Okay, can we do a sense check? the mean was 100, and I knew this value would be very close to the mean, since 40% is close to my 50%. So yeah, I'm happy that that's going to be an accurate answer, a sensible answer. 98.9868 is potentially the value of B. Okay, so once again, we use the diagram. We've used the alternate tables to find z-scores. We've used the standardization formula, and then we pull it all together with a little bit of algebra and rearranging to find B, which solved this problem. Okay, so the alternate table is very powerful in certain problems and how they've been posed. Let's get used to them.